Hello everyone and welcome back to my YouTube channel. In this video, we are going to discuss about vector databases and everything around it. If you are new to this channel, then this video is part of my GenAI and RAG series where I'm going to cover everything about GenAI, RAG, AI agents, RAG evaluation from scratch to production. And I have already completed the first module and we are learning the second module, retrieval augmented generation right now. I'll go to this video index now. In the previous video, we learned about vector embeddings. What are they? How are they helpful in RAG? So this video is the next part of that where we are going to learn about vector database. And if you have not seen that video, I will suggest you to go back and watch that video first to better understand this. So yeah, let's get started. So this video will cover about vector database, then distance and search algorithms, then code to convert any word, paragraph, anything to embeddings, then code to find similar embeddings. So let's start. Okay. If you remember in the previous session, we discussed this is what a RAG pipeline looks like. I have bought this from Llama Index documentation, right? So we stored something, we saw that we have some data, we converted them to vector embeddings, and every time when a query comes, we fetch this vector, we fetch relevant data from this vector embedding and pass that to LLM. But what will you do? There is one way, either every time you get a query, you can convert all this data into vector embeddings, or you can store it somewhere, right? So you can store it in your memory as well, right? But it's always better to store it in a vector database. So what is a vector database? It is just a simple database that is used to store vectors. Okay. What are vectors? Everything we learned in the previous session already. So why do we need a different type of database to store vectors? So the first most important thing is, if you remember about vectors, they are nothing but just numbers. That's it. 1, 2, 3, something like this, right? So they are not like our usual data where name, age, everything is stored, right? These are completely different. So that's why you will see in the market there are multiple different types of vector databases available, right? I'll quickly go through this doc and see what are vector databases, how do they work, and some use cases, right? We learned in the previous session that there is something called vector embeddings and they are stored in something called vector databases. So this is how a RAG pipeline works. I've already covered it in a video. If you have not seen that, make sure you watch that video first. So first thing that we do is we use the embedding model to create vector embeddings. Then we store this vector embedding into the vector database. Okay. So since we need to do multiple queries on this vector, right, which we have for our document, we store that into a vector database so that we don't need to pass it through the embedding model every time, and we have it stored already. And when the application receives a query, we use the same embedding model to create embedding for the query and then find the similar documents, right? We know all these things from the previous session already. Just the new thing got introduced is we are not just converting it, we are storing it as well into something called as vector databases. Why are they called vector databases? Because they are specially built to store vectors. That's it. Okay, now let's try to understand what's the difference between a vector index and a vector database. Not that important, but a vector database also helps you in multiple things. So basically it helps you, it is scalable. If you store it in just in your memory, you will not be able to achieve good scale. You will not be able to use it for wide amount of users, right? So if you have to use, if you are making a production level app, it's always suggested to use vector DB. And if you are just making a simple project, you can do it in memory as well. Then you can also store metadata, and metadata level store filtering is also available in this. What is this? So when you have some data here, I will quickly go through that. Let's say this data is coming from a PDF. This data is coming from a sheet. This data is coming from a web page. So when storing them into vector database, I can store some metadata also with it, like type web page. Like this data is coming from web page. This data is coming from this. So when I have to find the relevant data, if I'm using VectorDB, I can also filter it using metadata that only give me the relevant data from web page, not from sheet, not from the PDF, just from web page. Those type of filterings are also easily possible inside a vector database. They are inbuilt available in most of them. Then we have backups and collection, like other databases. They also provide backups, collections, all those things. Then they also provide data security and access control. So these all features are there in a vector database, which makes it a good choice while building a RAG pipeline for production. Okay, so if this makes sense, how does a vector database works? We know that it's very similar to our vector embeddings. We are just storing the vector embedding into that database. That's it. Okay, cool. Pinecone, the documentation that I'm reading, this doc that I'm reading is from a Pinecone, which is also a vector DB. Chroma is another popular vector DB, which we'll use mostly in this series. Now let's move to our next topic, that is distance and search algorithm, which is coming from this link. Okay, we all saw that how a word is converted into vectors, right? Now I think it's better to look at an embedding model first and see how a word is converted into vector, and then I think these things will make sense. So I'll go back to my code editor. Okay, I have already posted all this code to my GitHub repo. So and the link for that GitHub repo will be in the YouTube description. So make sure you start that repo. Okay, so the first thing I need to do is I'll use the OpenAI embedding model to convert any word into embedding. Okay, so I will first install all these library we saw in the previous session. Okay, and then I'll use .env to load OpenAI API key from my env file into here, right? Okay, now the next thing is you just need to call client.embeddings.create method to convert any text into embedding, right? So I've created a method where I'm calling this to convert any text into embedding. Okay, and then if I just use this method, let's say I have to check the get the embedding of apple. Apple embedding equals to get embedding of apple and print it. Okay, so let's see. So it converted the apple word apple into embeddings. Okay, now if I have to just print the length of apple embedding, C. Well, so 1536 is the length. What does that mean? Which means the word apple is represented into 1536 dimensions. In the previous video, I gave you a simple example where I represented the word apple into 2 dimensions. But OpenAI represents the word apple into 1536 dimensions to capture more and more semantic meaning of the word apple. Okay? So now I'll simply delete this cell. We saw how to get embedding. Then once you have all the embeddings with you, if you remember, these are the embedding, let's say protocol, Bluetooth are embeddings, right? In 1536 dimension plane. Then the most important thing is when you are trying to find out which two embeddings are similar to each other, how will you do that? You will find the distance between them, right? So then there are different types of distances. There is something called Manhattan distance, which is if 2 points are kept like this and this, Manhattan distance calculates the distance like this. Euclidean distance calculates the straight line distance between the 2 points, right? Similarly, cosine distance calculates the distance like this, okay? And then there is something called Chebyshev distance, which calculates the distance like this. I'll not go in depth. I'll just giving you a brief idea of what types of distances are there. Okay. Now, what you can do is which words are similar to each other. How can we find that? By finding the distance, any of these distance. In some case, we'll use cosine. Like here, if you look at this embedding, it by default cosine is selected, but I don't want the cosine similar words of session. I want Euclidean similar words. So I can choose Euclidean as well. Similarly, someone else can choose a different distance algorithm to find similarity, right? You can do that as well. So that's why these distance algorithms are also very important, right? Then how do you search what are the nearest element? Then for that, there is a very popular algorithm called k nearest neighbor. Like the query is about this word, so it will try to find out all the nearest neighbor of this word, right? Let's say apple, then it will try to fetch all the distant nearest neighbors like banana, any guava, all other fruits, right? But for k nearest neighbor, we know that it needs to calculate the distance from this word or this vector to all other vectors. Then only it knows that, okay, this one is closer, this one is farther. So I just need to fetch the first k, which is this, right? So, which is not a very optimum approach. So to find the distance of all the words in this vector space is not optimum, right? So for that, what we use is we use approximate neighbor search algorithm, right? So it works on a good guess algorithm, right? I will not go in depth of that, but this algorithm is used. Maybe I can create a whole new video about the whole search algorithm because that will go very long. I'll keep this video short, so I will not cover these topics in depth. But yeah, this is how a search is done, where one of the distance algorithm is selected, and then you also need to select a search algorithm. In most cases, what we do is we by default we choose approximate neighbor search, right? Okay, so this was about similarity search. Now let's see the same thing into code, how it looks like. Okay, so I have created this function to calculate the cosine similarity between two vectors. So we'll have two vectors of 1536 dimensions. Okay, how will we do that? We can use the NumPy algorithm. You can do ChatGPT or anything to find the cosine similarity code. This is how you will do that. You'll find the dot product of these two vectors and then you will do this. That's it. Now, let's compare the embedding of different words to see if they are related. Okay. Let's take two words, freedom and liberty. We called our get embedding method to get the embedding of these two words. And then we called our cosine similarity function to get the similarity of these two. So let's see. It says that the similarity between these two is 0.72. Now, let's try to find out the similarity between some completely non-related words like freedom and, let's say, fish. Okay. It gave that. So, how will we know that which word is more related? We know that in cosine distance algorithm, if the distance is 1, then it means they both are similar to each other. If closer to 1, which it means they are similar to each other. If it is -1, then they are not similar to each other. And anything between 1 to -1, like if it is 0, closer to 0, which means they are not related to each other. And if it is -1, they are completely opposite to each other, right? Okay. So if we saw that when we gave freedom, liberty, and fish, we saw that freedom and liberty gave us 0.72, but freedom and fish gave us 0.24, which is closer to 0, which means freedom and fish are not related to each other, but freedom and liberty are related to each other, right? So this is how you can, by just looking at the embedding, you can still see the meaning of these words that, okay, if you are an AI model or anything, you can still see the word and recommend that, okay, I can at least say that this word is not related to this word and this word is related to the other word. These are the advantages of using vector embeddings. Okay. Now, I'll not discuss the code for vector databases in this session. We'll write the code for this in the next session directly, where we'll build a RAG pipeline. And first, we'll build the RAG pipeline without using any framework like LangChain or Llama Index. And then we'll try to build a RAG pipeline using those library and see what advantage those library provides. So next videos are going to be very, very interesting. We are going to build a great project using great RAG pipeline. So make sure you subscribe this channel and share this video with your friends and your college group. Don't forget to comment whether you like this video or not. Whatever you liked, make sure you write that in the comment section. And yeah, don't forget to subscribe this channel so that you keep on learning this GenAI series. Okay. Thank you, everyone.